Um, I think Nick already referenced that you've got on your island some really fantastic genetics in your cocoa trees. Over a little over 95% of the genetics of the cocoa in Jamaica is going to be what's classified as fine flavor cocoa. So you've got fantastic trees to work with today. As a result, we're not going to spend any time talking about the genetics of the trees that you've got because they're outstanding. They're really, really good. We're really going to talk about what happens with those cocoa beans once you pick them from the tree. Okay. So that's to set it up a little bit here, and let me go into presentation mode. We're going to talk about what is fermentation, why do we do it. We're going to talk a little bit about some of the different fermentation methods and some things that drive either good quality or poor quality. And then we're going to take a walk through very specifically what's happening at each step in fermentation. And I'm going to talk about some of the equipment or some of the tests that we can do to understand if your fermentation is doing what you think it should. So at very basic level, fermentation is, as applied to cocoa, fermentation is when yeast eats the sugar in your cocoa beans. Now it's a lot more complicated than that. And there's, some chemistry charts up here that we're not really going to go through in detail. But basically, it's when the yeast in the air eats the sugar in your cocoa beans and turns it into something else. And through that process, chemicals are developed that will allow your cocoa beans to taste like chocolate. It's the first step in making sure that we've got a chocolate that's going to taste. I'm sorry?
On a laptop, do your schoolwork?
Can you say that again?
If I can ask about how this something to laptop and how this something to do not fast enough.
Let me see if I can pull up the chat window. It's not coming through clearly. All right. So I've got the chat window open up now. If you could type the question in the chat, I'll read it. I'm not. The voice isn't coming through clearly enough for me to understand it, unfortunately. Okay. So fermentation is the very first thing that has to happen in order to make the cocoa beans be able to taste like chocolate. If we skip fermentation, it doesn't really matter what happens to your cocoa beans, but they will never, ever taste like chocolate unless we ferment. And it's also important to note that all of the yeasts and all of the bacteria that are required for fermentation to happen are already naturally present. They're in the air all around you, and there's really nothing that you need to add in order to make that fermentation occur. There are some companies that will try to sell you specialty yeasts or specialty fermentation starter kits to boost fermentation. It's not necessary. It's not going to hurt anything, but it's also not necessarily going to help anything. All right, so of course you guys are all familiar with this, the pod opening. What we're really looking for are mature beans, and you know that your beans are going to be mature when you open it up, and this pulp is slippery and sweet. We'll look at what immature pods look like and why we don't want them in fermentation here in a little bit. But one of the other interesting things is that oftentimes as you split your beans in a raw, yes.
Are you sharing that on screen? Because we're just seeing the main screen, the first slide.
Yeah, so you should be seeing, hold on.
You could stop the share and then you reshare.
Okay. All right, I'm stopping and I will restart. Thank you for calling that to my attention. Can you guys see a Cocoapod now?
Yes, yes.
Yeah.
Okay, yeah, so not sure what happened there, but thanks for letting me know. If it happens again, just give a shout out.
No.
So one of the interesting things is that you can see from the picture, and I'm sure you guys are all aware of this, that on a raw cocoa bean, if you cut it open, oftentimes there'll be purple inside. And that purple is due to a class of chemicals called flavonols, which are very good for your heart. When we hear about people talk about chocolate being heart healthy, it's because of those purple, that purple color in the bean. And we can talk maybe in our advanced fermentation conversation on next week about what happens to those heart healthy purple things when we ferment, and what are the pros and cons of keeping them versus making them go away. But for today, we're not going to spend much time on that because that's a little bit more of an advanced topic. All right, so common ways to ferment around the world. And we're going to look at 4 of them just really briefly. The first one that's most commonly used, typically in Africa, is going to be what's just called a heat fermentation. And essentially, it's just piling your beans on banana leaves or some other type of leaf on the ground. It's very, very commonly used with farmers who only have a handful of trees and maybe don't generate a tremendous amount of beans. And the benefit of this is it's a very inexpensive way to ferment. I don't particularly like this way because it's very, very difficult to control and gives lots of issues with consistency. So if you're trying to make a certain type of flavor and you want that flavor to happen from batch to batch to batch to batch, fermenting in a heat fermentation is very difficult to get that to occur, partially because there's usually not enough beans there to achieve the right temperature required to be able to develop flavors. And we'll look at what that means here in a couple of slides. This method is also very vulnerable to theft. And so you can imagine if you're in your plantation and there's maybe a dozen small piles scattered all throughout, it's very easy for somebody to walk up with a bag or a box and to steal your beans and bring them back to their place. So I'm not a huge fan of that for a couple of reasons. Box fermentation, this is almost always going to be my preferred fermentation style. And typically, so a couple of things you'll notice on this box is that this box is vented, right? There's holes on the sides and the bottoms, and we'll talk about why that is. And oftentimes I'll construct the boxes with a removable front panel to be a labor-saving device. And we'll look at why that is here in a minute. Typically, these are made with local woods because it's very inexpensive just to use local trees to be able to create the boards to create the boxes. I've also built some fermentories around the world. In fact, 2 of the largest fermentories in the world I built where we use plastic boxes. Obviously, it's much more expensive to use plastic boxes. There are some reasons that we did that, but it can be a very, very expensive way to go and isn't necessarily needed in all types of fermentation. This does allow you to have very, very consistent fermentations. And so once we identify what the fermentation is that we want, that's going to give us, that gold star chocolate that is going to drive tremendous value. I think, Nick had referenced that once you get that notoriety that your beans will create the most beautiful chocolate on the planet. And it's not just in Jamaica that you're competing. The Cocoa of Excellence Award is everywhere in the planet. So you're going to be competing with beans from Panama and from Africa and from Asia. And once you rise to the level where you're an award winner on a global stage, your beans become really, really valuable. Having a controlled fermentation ensures that when your customer gives you that $10,000 a ton for your beans, that they're going to get the same thing they expect every single time. So this is a really great way. And as we start to talk about the potential of maybe running some trials to develop the high quality beans, this is going to be the recommendation that I go with. In some parts of Asia, basket fermentation is very common as well. It's a little bit of a variation on a theme from this heat fermentation in that small scale farmers will be doing this. Typically, they put it in baskets because then they can bring that basket back to their house and prevent theft. But again, concerns with this is that it's at such a small scale that it's difficult to regulate the temperature. And as your temperature drops at night, your temperature of your fermentation will also drop, and that's going to change the flavors that are being created. If you get a basket that is able to hold the same amount as, say, a box, well, now you can't move it. It's just too heavy, and there's no benefit to having a basket. So basket fermentation is used. It's just not a very consistent way to do things. And there is another way to ferment that's becoming more popular, specifically in Africa and some parts of South America, called a tray fermentation. And essentially, it's a series of stacked boxes, right? So you've got this box is stacked upon this box, upon this box, upon this box, and each layer holds about 4 centimeters or about 2 inches worth of wet beans. And the thought process here is that as you do this, you're getting airflow coming up through your beans, right? It comes up through the bottom and out through the top, and that's creating some flavor compounds that are really, really interesting. It's true, it does do that. It's a very, very labor intensive thing to do because you have to lift each one of these trays to stack them. They're heavy. The bottoms break because they're full of beans, and the wood mesh gets wet and they break through the bottom. It's just a difficult thing to do. On Monday, I'm going to walk through sort of a more advanced version of this as a proposal to you guys, specifically around creating very, very specific chemicals that will drive very specific flavors that are sought after in Cocoa of Excellence Award cocoa beans. And this will be a fermentation that nobody else does in the world because it's we haven't deployed it anywhere yet, but it's probably patentable. And so if it works, I will give it to you guys to patent if you so choose to do it. And then you can own that and drive huge amounts of value to your cocoa businesses. The downside of this, in addition to labor, is that because there's so much air flowing over your beans, if you don't control it really, really, really well, your beans can get sour very quickly. And we'll talk about why that is here in just a minute. All right, so what are the 4 stages of fermentation? We're going to think about fermentation in terms of these 4 stages. And the very first one, when you open up your pods and you put them into whatever mechanism you're using to ferment, is you're going to have a yeast fermentation. So a yeast fermentation is what us scientists call an anaerobic fermentation, which is just a fancy way of saying that the yeast doesn't want any oxygen to be present. And so if you think about your beans, right, they're this mass of pulp that's all sticky. And yeah, while oxygen is maybe touching the outside of your beans, on the inside, where you've got this big pile of beans in a box or in a bag or on a heap, most of your beans are on the inside, and the oxygen cannot get into the center because your beans are so wet and sticky, they're forming a shield around the center. So in the inside of that, where you've got your wet beans with lots of sugar, and the yeast from the air, that yeast is going to start to eat the sugar and convert it into alcohol, which is really important for killing the beans and for some flavor chemistry that's happening inside your beans. And it's going to change it also into carbon dioxide that will just boil off and go into the air. When that happens, you're going to start to create some temperature, and your temperature is going to go up and up and up, which helps also to kill your beans. But that temperature rise is really important because it will allow the next stage of fermentation to happen, which is what we're going to call the lactic acid stage. So you can see, and this chart here early on is meant to show just generally speaking, early on, you've got your yeast fermentation, right? So this red line corresponds to this red box over here. And as your yeast fermentation starts to peak, your lactic acid bacteria, which is your phase 2, really is at its peak as well. And what's happening here is now you've got a specific kind of bacteria that is converting the alcohol that your yeast produced into something called lactic acid. Now, lactic acid is a really, really weak acid that is going to taste just a little bit sour. It usually is difficult to taste in chocolate because it's not really all that sour. It's just a little bit sour. But if this goes haywire, you can generate enough of it where it will start to create sour flavors that you don't really want. That's almost never going to happen. Really, from a sour perspective, what you're going to be worried about is this third stage over here, which is your acetic acid bacteria. So as you work through these stages here, your yeast is eating all the sugar. Eventually, by about day 3 or 4, it's eaten enough sugar away, the oxygen can now get into the center of the pile, and that oxygen is going to start to feed this acetic acid bacteria, and it's going to create vinegar. So acetic acid is just another way to say vinegar. And I'm sure you guys who are cocoa farmers have, you clearly recognize that maybe a half a week into your fermentation, and your beans start to smell a little bit different. And it's because at this stage, you've got a bacteria that is turning your sugar into vinegar. It's usually a good thing if it happens at low levels. If it happens at very, very high levels, it's going to be considered a defect in your chocolate, and nobody's going to really want to buy your cocoa beans. And we'll talk about how you control that. So most fermentations go for a maximum of 6 or 7 days. If you let it go more than that, you start to get into this fourth section here, which is going to be the moldy stage, and nothing good happens in moldy stages. We'll talk about specifically what's happening in there. You're going to generate some toxins, some poison. You're going to create some terrible flavors that can't be fixed. So you always want to be able to control your fermentation and stop it well before it gets to the moldy stage of your fermentation. I know that's a lot of science and a lot of technical terms there. Any questions on this before I move on to the next one? Okay, we can come back to that for sure. All right, so now what we're going to do is we're going to take each one of those phases, right? So we're going to take, we're going to take this yeast phase and this lactic phase and the acetic acid phase, and we're going to look at each step in this process, what's important for this to behave the way that we want it to behave. So in this first yeast and lactic phase, it is really, really critical that we start with mature pods. So I know early on that we looked at a pod where we had the beans cut in half and you could see the purple in it, and it was nice and loose and the pulp was slippery. And that's all a good sign of a pod that's mature and ready to harvest. However, lots of times it's difficult to tell if your pod is mature or not because it's on the tree and there's a shell on it. You can't see inside of it. If you open up that pod early and it looks something like this, where it's really densely packed and it's all this white stuff in here is starch that will eventually turn into sugar that becomes that slippery pulp around your beans. But early on, it has not yet, the tree has not yet turned this starch into sugar. And if we try to ferment this, it's just not going to ferment because your yeast needs the sugar in order to ferment. So if we try to ferment this, what's going to happen is we're going to get, we're just not going to get any of that alcohol formed. We're not going to get any of the lactic acid being formed. And we're not going to get any of the acetic acid being formed because the yeast is unable to convert the starch into sugar. One of the side effects of not having your fermentation progress is that not only will you have very poor flavor, but your fat levels in your cocoa beans will be low as well, which will be a real problem for your customers. And we'll talk about why that is so you can understand how do you maximize the fat in your cocoa beans, because that's what you're, in addition to flavor, your chocolate manufacturers are looking for high levels of fat because it helps them process their cocoa beans. All right, so this is really what we're looking for in terms of a cocoa pod that's mature and ready to harvest. This is gonna ferment really, really well. If we try to ferment the last thing, you're gonna run into all kinds of problems. So how do we know if this pulp here is gonna be fermentable or not? We could open it up and we can kind of rub it between our fingers and kind of go, yeah, I think that's slippery. We can taste it and go, yeah, that tastes sweet, but that's not a very objective way to measure it. So there is a piece of equipment called a refractometer that we can use to specifically look at the juice in this pulp and determine how much sugar is there and if it's going to ferment for us or not. So this is an example of a refractometer. It's a really, really inexpensive piece of equipment. I think I got, you can buy these off of Amazon, for example, for $20 or $30. And the way it works is that, hope you can see this, that there's a piece of glass here that will let light through. And what we do is we take that pulp that you see in that picture there, and we put it in our hand and we just squeeze it until it drips. And they go drip, drip, drip. And we want to put it on this piece of glass right here. And it works on the premise that when you shine light through something, that light will bend a little bit. And so if we've got liquid on here that now has sugar in it, if there's a little bit of sugar in it, it will bend the light a little bit. If there's a lot of sugar in it, when we look through here, it's going to bend the light a lot of bit. And when we close this, and there's an eyepiece on this side,
I'm not seeing that.
What's that?
I'm not seeing that what you're showing at the moment.
You can focus it a little bit closer so they can see the actual refractometer, just maybe a sideways view. That's it.
I've got it about as close to my camera as I can get it.
No, all I'm seeing is the last slide.
All right. Well, let me stop sharing and start sharing again. Sounds like I may have froze for us once more.
That's better.
All right. Are we able to see the refractometer now? You know what? I wonder if I'm.
It's in its hand. It's not on the screen, guys. So don't look at the slide. Look at the picture on the screen.
Suggestion though.
Yeah.
Right.
Could we, just put the name in the chat and we could look at it on Google or somewhere? That you could get a better.
I'm doing that now.
Yeah, I think it would be best if we look at it, in somewhere else.
Yep.
Because it will be difficult to see it here.
Right.
Yep.
I think. Yeah.
So what we'll see, guys, and we can put that in the chat, and you'll get a copy of this as well. But what we see, so for those of you who can see me on the screen, when I look through this eyepiece, what you'll see is a chart inside of here that looks like this. And where this blue line is, that's telling us what's called the bricks. Now, a bricks is another one of those terms that us technical people use. All it means is what the percentage of sugar is. So on this particular example, because the blue line is right at 30, that's telling me that what I'm looking at through this refractometer has a bricks content of 30 or a sugar content of 30%. Now, why do we care? So for cocoa, what we're going to want is when we take this cocoa pulp and we squeeze it onto our refractometer, we want at least 13 bricks. We want at least 13% sugar in your cocoa pulp, because that's going to be the minimum amount of sugar that the yeast needs to have to be able to ferment and develop the flavors that we want. It doesn't really matter how much higher it goes. It can go as high as you want. In fact, more sugar is almost always going to be better, but you're always going to want at least 13 bricks in order to start your fermentation. If it's less than that, what that's telling me is that something has gone wrong. Either your pod is not mature and it needs to spend more time on the tree, or that there's an infestation and a real disease issue where something has already it's gotten inside your pod and it's already started to, quote, eat the sugar that's in your cocoa beans. And now what's left is insufficient for us to have a good fermentation. Okay, so, and again, I know everybody can't see what's on my camera here at the second, but for those of you who can, this is what a refractometer looks like. You can buy them for $20 or $40. This one's a little bit more expensive just because it's my personal one. And I can give a link to you guys in terms of what a good refractometer would be for you to have. But in terms of cocoa farms being able to have simple tools that are really durable. I can put this in my pocket. I can carry it around. It doesn't require any batteries. It doesn't require any special usage instructions other than I just need to put it up to my eye and be able to look through it. It's a really, really durable, easy to use, inexpensive piece of equipment that will make sure that the cocoa beans that you're starting with are going to be able to have the potential to turn into really high quality chocolates later down the road. Okay. The other thing that a low bricks could tell you is that in some parts of the world, because oftentimes, and this is usually where there's a central fermentary involved. So in those parts of the world where farmers are growing their beans and then bringing them someplace else to be fermented, where they sell their beans to a central fermentary, because in that model, the farmer's getting paid by weight. I have seen some instances where farmers will add water to their cocoa beans because it adds weight, and that can help explain why your bricks is low. So if you started with good high bricks and there's water added to it to add weight, that will depress your bricks level, and now you've got less sugars because you've added more water to it. Nobody here is going to be doing that, but that's just another thing that I've seen somewhere else in the world where people have added water because it adds weight.
Hi, Scott. Just a little. Could you explain, for example, or the best way to get that sample that you would use the refract that instrument to test? How do you get a good composite sample to use?
Yep. So that's a great question, and it's really, really straightforward. So again, for anybody that can see me on the screen, what I would do is as you're opening your beans, and now you've got a pile of beans, be it either from a single pod or because you've opened up 20 pods and now there's a pile of beans there. Take a handful of those beans, bring your refractometer with you, open up this gate here that again you hopefully can see on the screen, and then just it's literally as easy as taking those wet beans in your hand and squeezing them, which will squeeze out the juice in your beans. That juice will drip onto the top of this it looks like a black plate right here, and then just close it up and look through it. It's really, really very straightforward, and there's very little preparation that needs to be done other than squeezing the juice out of your pulp.
Now, Scott, just a bit of clarity. You have a pile, but you want to make sure that you get the best sample you can. You just mix it in and just take a handful and squeeze it. That's what I'm trying to understand.
Yeah, yeah.
And it's not how you use the machine, it's how you arrive at the sample to extract that juice that you're going to use to represent that batch.
Yeah, got it. Good question. So it depends a little bit on how you're sourcing your beans, right? And so let's say you're a farmer and you are taking only beans from your tree. So you're in full control of your supply chain, right? And today we go out and we're harvesting beans, and I started, let's say I started at 5 o'clock tonight, and I pulled off, 1,000 pods from the tree, and I've made my own pile. Probably what I would do if I'm in that case is, if I'm going to be fermenting myself, I will every hour or so, or maybe I'll go tree by tree and just say, all right, what am I getting off of this tree? Or what am I getting off of the last hour's worth of my production? And being able to take a composite there and say, all right, well, am I confident that everything that I'm putting into my fermentation is fermentable or not? If you're not that guy, right? If you don't have your own trees and you're not in control of your own pods, but maybe you're a central fermenter where you've got product coming in from lots of different farmers. Maybe they picked their pods last night. Maybe they even picked them the day before. Then what I'm going to do is probably want to put in a statistical sampling program where I don't want to spend a lot of time today talking about that, but what I'm going to want to do is start to sample. If it's coming in bags, I'll probably use a special instrument called a thief, which is, it's a stick that's hollow. You poke it into the bag and you pull it out, and it samples all along the entirety of that bag. So you're getting, some of your cocoa beans are at the top of the bag, some of them are at the middle of the bag, some of them are at the bottom of the bag. But what happens is then you get a representative sample of everything that's being brought for you. And then and I don't know the number because we're talking hypothetically here, but maybe every 10 bags or 20 bags, I will do that, pull a sample of that, and then use that as my way of getting some understanding of, are my beans high Brix beans or low Brix beans? So if you've got specific scenarios that you want to talk through, I'm not quite sure who this is, but let's maybe not do this on this call today, but maybe send an email to me, or we can have a conversation later around helping me understand your specific scenario, and then I'll share my thoughts as to how would I specifically create a sampling program to best represent your specific scenario.
Yes, Scott, that is adequate for me. I get the scenario that you're showing. How you could do it.
Okay.
So I'm okay with that.
Okay, perfect.
Thanks.
All right. So that's all right. So we've talked about making sure you've got mature pods. We've talked about making sure you've got pods that have enough sugar in them and how to measure that. The other thing that I really want to emphasize is that it is critical that your pods and your beans be disease and damage free at this point. And I know that in Jamaica, you've got some serious disease issues that you're struggling with right now. So all around the world, everybody has disease issues. Here's black pod from South America. Here's one where a woodpecker poked a hole in it, and now we've got yeast inside eating this from the inside out. And you've got frosty pod and white pod issues there, right? So everybody has disease issues all over the world. It's just that the nature of the disease changes around the world. What happens though, if you try to ferment this, so if I took this black pod and I tried to ferment it, what I'm going to get is a really, really poor flavor development. And so this is going to result in a cocoa bean that does not have the potential to create a chocolate that will be considered a gold star chocolate, no matter what we do with it. So it is going to be really important to manage your disease state so that you're not putting diseased pods into your fermentation. And I get that it's really difficult not to do that, right? Because again, farmers are compensated by weight, and a diseased pod still has weight to it. And so it can be really tempting to put that pod into your fermentation. If you do that, you're going to lower the overall quality of your chocolate from both a flavor and a fat perspective in ways that can't be fixed later down the road. And if you do that, you're going to generate lower income from your pods, from your cocoa. Whoop. So this is a picture I took in the Ivory Coast, where they have a saying that basically translates through to "there is no grave for cocoa," meaning that this particular village doesn't, they never throw any of their pods away, regardless of how, if they're diseased or not. And so based on what we just talked about and looking at the fermentation pile in the front of the picture, do you see anything that might be problematic with this fermentation pile? All right, so you may just be muted.
Discoloration.
Yeah, so there's pretty significant discoloration, right? And to the point where we've got a number of rotted pods in here, right? These are all masses of black peas that are pretty heavily diseased. And just looking at it, it's maybe 5 or 10% of the overall heap. This heap, even though 90% of the beans, like this is a fantastic beans right here, these beans are going to be insufficient to overcome the problems that these beans are going to cause. And so this pile itself is going to, even though it's only 5 or 10% of diseased beans in it, is going to be considered a really, really low quality ferment because it's just going to be really, really problematic from a flavor standpoint. So these farmers are not going to be able to get much value for the cocoa that comes out of this pile, even though they're trying to maximize their value by putting these, this weight into it. From an immature standpoint, here I did a number of tests all around the world, actually, where I wanted to understand very specifically when you put immature pods into a fermentation, exactly what's happening. So exactly, there's thousands of chemicals that are generated in fermentation. Exactly what's happening when we put immature pods in there with all of those chemicals that generate into flavor, that turn into fat, that turn into other things. And one of the hallmark signs of an immature pod is that these beans are all stuck together, right? That starch that has not yet turned into sugar is going to act as a glue and will glue all these things together and be part of the issue with fermentation. So these clusters are going to be very, very light in color. They're going to have poor flavor. They're going to generate something called a free fatty acid, which is a part of your fat. Typically, we don't think of fat as having any flavor. When we put either diseased or immature beans into the mix, though, they will break apart the fat and turn it into something called a free fatty acid, which is going to have a really, really poor flavor. Think of it almost, if you've ever had something that was fried in oil that has gone bad, that rancid flavor is going to be what these will generate in your cocoa and in your chocolate. So lots of reasons to keep immature beans out of your mix. Every continent that I've done this on, and this code here stands for, this is my 5th repetition in 2 fermentation boxes, with the L being a location code. This is the city I was working in Indonesia. It just helps me keep track of specifically where this picture is from. Every place I've done this has given the same result. So it doesn't matter what the genetics are of your tree. It doesn't matter which location you're on. The same thing happens with immature beans all around the world. So be very careful not to include immature beans into your fermentation. All right, so we're still on the yeast and the lactic phase. Fresh beans look like this. Again, they're very, very pulpy, lots of moisture in here that prevent oxygen from getting into the center of your fermentation. And as your fermentation proceeds, it becomes a little bit less pulpy, a little bit less pulpy. And now we're starting to see holes where this liquid was before. And now oxygen, right, your air can get into here and start to move on to the next phase. And so part of what's happening over time is, of course, your color is changing. And we're going from this nice white milky to to this brownish color, well-fermented bean. And that's a good visual sign that things are doing what they should be doing. We talked a little bit about temperature is going to be increasing because as your yeast eats that sugar and it makes alcohol and carbon dioxide, when it does that, it's also generating heat. And so if I were to take a thermometer and stick it into my fermentation pile, I can measure the amount of heat that's being generated over time. Because this goes up and down and up and down and up and down, this temperature profile is telling me something about how the beans are being treated. So each time it goes up, I can tell at this point, somebody did what's called turning the beans, right? They're mixing them up. And when you mix them up, basically what you're doing, the reason why you're turning your beans or mixing them up is that's injecting fresh oxygen into your mix to be able to create the acetic acid phase of your fermentation. When you do that, remember fermentation creates heat, and think of oxygen as the fuel for your fermentation. So here we turned the beans, we injected a bunch of oxygen, all of a sudden the temperature goes up because our fermentation is now more vigorous. It's fermenting more effectively, it's fermenting faster. Here I can tell that we also turned the beans because we had another spike in temperature. Okay, so if we do this over and over and over, what I can get is a graph. And again, I'm going to hold up something called a data logger for those of you that can see the camera. What a data logger is, it's a miniature computer. This one I think cost $50. And what I can do is open it up and it plugs into my computer with this USB port right here. And then I can program this to do to measure my temperature or my humidity or whatever it is I'm looking to measure as often as I want it to. So I can tell it every second or every minute or every day or every hour to take a temperature reading, and then it stores it. Now, when I do this over thousands of fermentations, what I get is a picture that you see down here, where after 24 hours, this green, and this is over thousands of fermentations where this was a 4-day fermentation that I was turning at exactly at 48 hours. What I can do is if I'm measuring the temperature of my fermentation, this green line tells me what my average temperature should be. And then the red line tells me what's the warmest it ever got. And the blue line tells me what's the coolest it ever got. And I can use this to create a process specification to be able to know that after 24 hours, if my fermentation is anywhere in this range, I've got a really, really high comfort level that it's doing what I think it should be doing. And that those beans that my customer is expecting to be consistent are going to do what they want them to do because my fermentation is it's behaving the way I expect it to behave. So after generating this chart, this fermentation chart, I no longer need to put a data logger into my fermentation box to measure it every second because I've done it hundreds or thousands of times now. And all I need to do is walk by with a stick thermometer, once a day or once every couple of days, put my stick thermometer in there, get a quick reading on it. And again, if at 72 hours, it's anywhere in this range, I know that it's doing exactly what it was supposed to do. Now, on this specific fermentation, I put the beans into a box, I let it sit, let them sit, let them sit, let them sit. And then here at 48 hours, so 2 days after I loaded the beans, I turn those beans into another box. When I do that, I take my data logger out, right, because it's in the middle of my fermentation. That comes out. I move the beans from this box to that box. My temperature drops briefly while my data logger comes out of the fermentation. I move them into the new box, put the data logger back into the fermentation pile, and you can see immediately there's a spike in the temperature. And that makes sense, right? Because we just talked about when you put more oxygen into your beans, your fermentation uses that oxygen as fuel. And that fuel is producing the acetic acid. And we'll talk about why that's really important here in the next slide or two, and how do we manage that. So before I move off of that, let me just kind of stop and make sure that I explain that correctly, and see if there's any question on temperature as a result or a function of fermentation. Okay. All right, so I've talked a couple times here about turning the beans. And why do we turn the beans? Well, a couple times we've talked about turning the beans as the way to get oxygen into there, which allows your acetic acid bacteria to produce vinegar, right? That's what acetic acid is vinegar. Now, when we do that, a little bit of vinegar is a good thing. You're going to want some of that in your beans, and a lot of vinegar is typically going to be seen as a problem. The more frequently you turn your beans, the more fuel, right? The more oxygen you're putting into your fermentation to create more vinegar. And so here's a fermentation setup in Ecuador where it's a 6-turn fermentation. So we load our fresh beans in the top, and every 24 hours, what I'll do is I'll take this front of the fermentation box here, lifts up just to make it easier. Because what I'll do is all our fresh beans are in this top box. I'll lift up this gate that's now in the front. I'm using this because we can see it in the picture, but this gate is the same gate that's up here in the front box. I'll lift those boards up so that I can take a shovel and just push my beans from this box into the bean box right below it and let gravity do my work. Beans are heavy. I don't want to shovel beans all day. If I can just push them out of the box and let them fall into the box below it, that's a way for me to not get so tired all the time, right? Why I'm doing that, the real reason I'm doing that is I'm trying to get more oxygen into my beans, right? So I turn the beans from this box to this box. I let it go for a day. I do the same thing. I lift up this gate. I push the beans from this box to this box. I put more oxygen into it. My fermentation now burns hotter. I'm creating more acid. And I do this every single time. So by the time I get down to this box, I've injected oxygen. I've turned the beans 6 times. Let me compare that to this one over here. This is a facility I built in the Dominican Republic where it's a 3-turn fermentation protocol, right? So I load the beans into here. I'll remove this front panel, turn them into this box, inject the oxygen into this box, and excuse me, let me get a drink. So I'm injecting oxygen 2 times, right? Turn once, here's an oxygen injection. Turn twice, here's another oxygen injection. Each time we do that, we're creating more more acetic acid bacteria fermentation, more vinegar. So based on what we've just talked about, guys, which one of these beans is going to be the bean? And if vinegar is sour, right? It's an acid. Acids taste sour. Which one of these fermentations is going to create a bean that's going to be really, really sour? Is it the 6-day fermentation where we've turned it 6 times, or the 3-day fermentation where we've turned it twice?
The
6-day.
Exactly, you've got it, right? So the 6th day, we've created a ton of vinegar, and this specific customer wanted a really, really sour chocolate. I will guarantee you that most of your customers do not want that, right? So your goal in fermenting beans for the Cocoa of Excellence program is not to create a sour chocolate as possible. So now that we understand a little bit of the chemistry behind what generates sour, that will help us design fermentation processes to be able to manage our sourness in an appropriate fashion. Sour is also, drying is also really important when it comes to managing sour. We'll talk about that on Friday, but for today, what I want you to really clearly understand is that the more frequently you move your beans around and the more frequently you put oxygen into your fermentation system, the more sour your beans will become. So a couple other things that we see here that are important. One, both of these fermentations are under roof, right? I've got a ceiling above both of these. And the reason I do that, or the reasons I do that, are one, I don't want rain to fall into my beans, right? If I get them wet, that's going to cool them down and it's going to drain my sugars away. And my sugar is that's the fuel that my fermentation needs to be able to ferment. So I always want to cover my fermentation to keep the rain out. The other problem is exactly the opposite problem. If I don't cover this fermentation, and yesterday we got a meter of snow and it's overcast where I live. It's probably not the same thing where you live, right? You have way more sun than I have here. So where you live and you're fermenting these beans, if there's no roof here and it's not raining, that means that the sun is beating down on your fermentation. And when that happens, you're going to get some just crazy fermentation things that are happening. We want to be able to manage the heat We don't want the heat of your fermentation to come from the sun. We want it to come from the fermentation itself. And so it's always going to be important to cover your fermentation to protect it from the elements. The other thing that's worthwhile noting here is that it's a little bit more visible in these boxes, but you can see there's holes drilled all through these boxes, and you can see there's liquid running out of them. If we could see the bottom of these boxes, we'd see the same thing. I drilled holes in all the bottoms of these boxes. These boxes have the same thing. It's a little bit more hard to see because they're plastic. But why would I want to drain the liquid out of my fermentation, do we think?
Not sure about that, but there was a question earlier, I don't know if it relates to this one, from Colette. She says, does the more juice make bricks based on watering the plant itself? I'm not sure if I got what she was asking.
Yeah, let me turn to let me see if I can open up the chat so I can see it myself. Does the more juice make bricks based on watering the plant itself? So I may not be understanding the question. If the question is, if you water the cocoa tree more, will it make higher bricks? The answer is no. That may not be what you're asking, though. Oop. Shoot. Okay. Okay, so the reason that I want to drain the liquid in here is that, one, anytime you've got food sitting in moisture, you're going to increase the likelihood that it's going to rot, right? Think about things in your fridge or things at home. If you've got fresh bananas, by the time they get, if they're sitting in moisture, other things are going to grow on them and they're going to start to rot and they're not going to be good. So that's part of it. The other part of it is, our fermentation is generating lots of alcohol and lots of, especially in the case of this one over here, lots of acetic acid. And I don't really want my beans just soaking in alcohol and acid. One, because if there's a lot of acid, that's just going to increase the sourness even more. So I want to get rid of that. From a chemistry perspective, and we won't talk through what exactly what's happening, but for flavor development, it's really, really important that your beans are exposed to both alcohol and acid, and those alcohol and acid will start to soak through your beans, and they change a lot of the chemicals that are occurring in your beans. But once it's gone through your beans, we want to get that out of there, because otherwise it's just soaking in there now. So we want to design a fermentation protocol that is generating alcohol and some acid. We want to make sure that all of our beans are touching that alcohol and that acid, and then we want to get it out of there. And we want to get it out of there so that our beans don't rot and that our beans don't just soak in alcohol and acid and become really, really sour. Okay. It looks like, can you use the juice for another purpose? If you're talking about collecting the juice that comes out of these boxes, those are sometimes called sweatings. Some places around the world will collect that and turn it into essentially an alcoholic beverage, a low alcohol beverage. It's not very stable, and so you'd have to kind of drink it really, really quickly to avoid it, growing other stuff that you don't want to grow in there. But because it's difficult to collect and capture that and store it for any length of time, it's not really a commercially viable product. But there are some places around the world which will capture those sweatings or that cocoa dripping and then drink it relatively quickly. Okay, so let me go back to this. So any questions on the purpose of the holes in the boxes and why I'm going to want drainage in our fermentation setup? Okay, and we can come back to that if there are. I want to talk a little bit about what's happening with fat during your fermentation. So I think I've mentioned a couple times now that if you have a poor fermentation, you're going to end up with low-fat beans. And all the chemistry that we've talked about to date, I've not said that we're creating fat. And so how in the world then, when we ferment our beans, if we're not making fat, right, our fermentation doesn't create fat, rather it burns sugar, it eats sugar, how does a fermented bean end up with more fat than a non-fermented bean? So and why do we care, right? So So your customer, the Nicks of the world, are going to want beans that are easy to process and flow, right? So they're going to make chocolate, and that chocolate has to be able to be poured into something. They pour it into a mold to make a bar. They pour it over a cookie to make a candy bar. It has to have a certain level of flowability for them to be able to work with it. That flowability comes from the fat, the cocoa butter in your cocoa beans. And so the more fat that's there, the easier it is for them to work with. If they work with low fat beans, they're going to need to buy cocoa butter and add it to their chocolate to be able to get to that high level of flowability that they need. And buying cocoa butter is just really expensive. So they would rather get the cocoa butter from the bean itself. So let's look at what's going on and why fermentation gives us a higher fat bean. So if we think just really generically about the stuff that's in cocoa beans, right? So all food is made up of basically 3 types of things. You've got fats. In cocoa beans, it just happens to be cocoa butter. We've got sugars, and then we've got protein. And those 3, let's call them building blocks, make up all of our foods. And so in this illustration, if our unfermented beans have, let's call it relatively equal amounts of each, here we would have a bean that is 1/3 fat, right? So about 33% fat. So there's 3 pieces of fat, there's 3 pieces of sugar, there's 3 pieces of protein, 9 pieces total. And if we take 9 divided by 3, we end up with 33% fat. So that's on an unfermented bean. Well, we don't work with unfermented beans, we work with fermented beans, right? And so as we go through the fermentation process, our yeast eats these sugars, right? That's what fuels the yeast. That's why we started with, what is fermentation? Fermentation is yeast eating sugar. So as we go from this unfermented bean to this fermented bean, where now our yeast has eaten all the sugar, we still have the same amount of fat and we still have the same amount of protein, but all of our sugar has gone away because our yeast has eaten it. And so now if we figure out how much fat is present, we're up to 50% fat. Not because we've created any fat, but because we've consumed the sugars. So does that make sense to you guys?
It does, Scott. I'm going to come in for just a moment. There's a really good question from Colette.
Yeah.
And Colette asks a question I see a lot, which is, what happens if you just wash the beans, break open your pods, wash your beans, and just put them aside and let them dry? And also, on top of that, we do a lot of bucket fermentations here, especially when we're making cocoa balls. Why isn't that the best way of fermenting cocoa?
Yep. Okay. So great questions. So washing your beans, there are some places around the world that will do that. Specifically in Mexico, there's, and in a very specific region, there's a practice called lavado, which just means washing. And so they will wash the beans. If you think about, again, fermentation is yeast eating the sugar, and that sugar comes from your pulp. So if we wash the beans, we wash that pulp away, and now there's no sugar for your yeast to be able to work. And so essentially what washing your beans does is creates a bean that is unable to be fermented. Well, if you now have a bean that is unable to be fermented, you are not going to be able to generate any of the alcohol that happens during fermentation. You're not going to be able to generate any of the acids that are generated during fermentation. And you're not going to be able to generate any of the flavor that happens during fermentation. And so let's call it conventional fermentation, the reason we do it is that it's creating chemicals that will eventually, once they're roasted and once they're processed, will taste like chocolate. If I take a bean that has been fermented, like I've got a pile of beans sitting here, this bean, for example, has been fermented, but it has not been roasted and it hasn't been processed. If I eat this bean now, it's not going to taste like chocolate. It's going to have the potential to taste like chocolate because my fermentation has changed the internal chemistry of this bean, such that once I roast it, it will, those precursors that were generated during fermentation will continue on their journey to be able to taste like chocolate. But a fermented bean at this point still will not taste like chocolate. If I don't ferment it, or if I take away the pulp and I wash away the pulp so that it can't be fermented, those flavor precursors never develop in the bean. And once I roast it, it's still never going to be able to taste like chocolate. So it's not to say that it's a bad practice. You know, there are some places around the world that do it, but it's never ever going to taste like it's going to lose the potential to turn into an award-winning chocolate. Okay, so I hope that answers the question. The other question was around bucket fermentation. And so I'm assuming the bucket is a relatively small bucket. And I think I'm going to liken it to, as we started the conversation, we talked about the different types of fermentation. A bucket fermentation is essentially going to be a basket fermentation, right? So it's a smaller fermentation. You do it because you don't have a lot of beans and because you can move the beans to a safe area. In your case, you're just using a bucket. Here in Asia, they were using a basket. The reason that we don't like to do that is because of, let me get to here, forward, is because you're not going to be able to regulate your temperatures here. So we didn't go into the specifics around all the chemistry that's happening with this temperature, but in order for the fermentation to be able to create a flavor precursors in this bean that will turn into a chocolate flavor, temperature is a critical component of that. And that's why I'm measuring the temperature of this fermentation every single second, literally every single second with this data logger, so that I can create a map of what normal looks like. And then I can come back with a stick thermometer and just plug it in there, and in 5 seconds know, is my fermentation doing what it should be or not. In a bucket, you're not going to be able to generate this temperature curve consistently. And so quite literally, every time you ferment, you're going to get a different flavor profile out of it, because sometimes your temperature is here and sometimes your temperature is here and sometimes it's over there, and it's going to be a really variable process.
Scott, if I may add, I believe that when you need to have a critical mass, you need to have a critical mass in order to generate that amount of heat alongside the yeast and the other fermenters. You need to have weight, not just the, in terms of that surface area to build up the pressure that will help to make the temperature higher.
That's an excellent point. We haven't gotten to that yet, but yeah, we'll talk about that. And so what he's talking about is that there's a certain amount of mass that's required to hit what's called thermal stability, right? And so if I've got, part of what so we talked about the bucket or this basket not having the ability to regulate its temperature, right? So if you've got, I'm going to make stuff up here. If you've got 5 kilograms in a bucket and you put that bucket outside and the temperature drops at night, well, that bucket's temperature is going to drop along with the temperature at night, because there's just not enough stuff in the bucket to be able to, not cool down as the night temperature cools down. Part of what, and I'm sorry, I just can't see the name, whoever brought up you need a certain amount of mass. Part of the reason why that's true is because once you get to a certain amount of beans in your box, that now is able to withstand the drops in temperature that happen throughout the day or throughout the night and not be adversely affected. At night, if your temperature drops by 10 degrees, your fermentation now has enough heat and enough yeast that are actively generating more heat to be able to ward off the temperature that's falling outside. The amount that is needed to do that is roughly 300 kilograms. And so if you're looking for consistency, what we're going to want is a fermentation protocol that is requiring at least 300 kilograms per box. Anything less than that, it doesn't mean that you can't ferment it. It just means you're going to create more variability in your fermentation, and more variability means less consistency. So on Monday, I'm going to propose that this group considers doing some trials to be able to, again, create a range of outstanding cocoa beans specifically for the Cocoa of Excellence Awards. Part of what I'd like to ask you guys about, and we'll get to this at the end of my time here, is how are you fermenting today and what sizes are you using? Are you using boxes? Are you using drainage? I'd like to better understand if you are willing to do some fermentation trials, and I can help. I've already designed some, but I can help design them further. If you are willing to do that, what do we have to work with today, and what what does normal look like for you today? But it is a really, really good question that, very, very small fermentations, people have tried to get what we call micro fermentations to work for many years. They're really, really difficult. There are a couple patents out there that will kind of walk you through how to do it. What those patents don't tell you are all the problems you encounter when trying to do it. So yeah, it's a great point. You're going to need a minimum amount of mass in order to hit consistent fermentations. Okay. Hopefully that, so as you see, we talked about what happens if you wash the beans. We talked about the bucket. And then, yeah, so the bucket doesn't drain away the juice. So same thing, we're now gonna have a variable fermentation because you've got temperature issues, and the beans are now also gonna be soaking in the juice. Sometimes it's gonna be more acidic, sometimes it's gonna be less acidic. Again, that juice is gonna be very variable because your temperature is gonna be very variable as well. Okay, so we've talked through a couple of the different phases. We've talked through the lactic phase, we've talked through the acetic phase, and of course the moldy phase is what we want to avoid. And so this is a fermentation that is right at the edge of 7 days, and you can see that we're starting to get some mold here along the side. Sorry for the grainy picture. This is one I took in Asia someplace years ago. I didn't have a very good camera, but we've got some white mold that's developing along the edges here. This is not a terrible thing at this stage. Obviously, our goal is not to generate any mold. A little bit of white mold is not necessarily a danger sign. It's a sign that danger is coming, and that you should stop this immediately and move it to drying. But a little bit of white mold is not a reason to panic. A lot of white mold is going to be a reason to panic. And if your mold starts to turn into colors, if it starts to turn red or black or green, that's a sign that you've now got something that's very dangerous. And so the reason it's dangerous is your colored molds are going to start to produce toxins. Specifically, they'll produce something called an aflatoxin or an ochratoxin. And those are some of the most potent poisons in the world, and you can easily die from them. And so we want to, and your customers can easily die from them as well. Of course, we don't, our goal is not to kill anybody. So we want to make sure that we're managing our fermentation so that we're not developing moldy products that are dangerous to people, as well as tasting bad. Your mold is going to start to create bad flavors that are not going to be able to be fixed with your customers' processing. So, again, after we go past 7 days, there's a really, really high likelihood that you're going to be getting molding showing up. I think that that's pretty unlikely for you guys because your genetics are just such outstandingly good genetics, right? Your trees have the ability, I think the rest of the world is jealous of your trees and your trees' genetics. There's no reason that I would see that we need to go to a 7-day fermentation because the genetics of your trees are going to dictate that we're going to be able to get outstanding cocoa in 3 to 5 day fermentations. This is some work I did to specifically drive to terrible levels of mold and understand exactly what's happening at a chemical level. Obviously, we've now moved into blue and green mold. This is very, very dangerous. And so one of the reason I put this on here is to, one, show you some of the color differences that can occur. If you've seen this, something has gone terribly off the rails. You're going to catch this way before this happens. But what we're going to talk about on Friday is the importance of drying your beans. And there is a scenario where your beans, you may think that they've been dried and you may think that they look fine, and you put them into a bag and you ship them overseas for your customer. And when they open them up, they look like this. And so now you're both scratching your head to say, well, they were fine when I sent them to you. And he's going to scratch his head going, well, all I see is a moldy mess of beans here. What happened? What's happened? Well, there's a couple things that can happen. But the thing that you can control is making sure you dry your beans to 6 to 8% moisture. If they're higher than that, they may look good when you send them, but when he opens them, they'll have molded during transit. And on Friday, we won't talk about it now, but on Friday, we'll talk about how do we measure that. Okay, so I was thinking about what might some general questions be that can pop up. And these are things that have, people have asked me this over the last 20 or 25 years. What's better? Do we ferment at the farm or do we ferment at the central fermentary? And I'd say both can be good, but my experience has been that typically you can have better control when you ferment at a centralized fermentary, because there you've got the best ability to standardize your weights. So for the gentleman who pointed out that it is important to have a certain amount of mass in your boxes, he's absolutely correct. And at a centralized fermentary, because you've got beans coming in from multiple farmers, my experience has been that that's where you've got the best opportunity to standardize your beans. Because I can take, if I need 300 kilograms in a box, I can take, 200 kilograms from Marcia, 200 kilograms from Colette, and 200 kilograms from Meldros, and combine them all into one box, which is going to work really, really well. Whereas on their own, they may not be able to generate enough mass to be able to do that. So if you've got enough mass to be able to generate 300 kilogram, or more is better, but 300 kilogram at the minimum, cocoa beans in a fermentation, absolutely. Farm fermentations can be fantastic. If not, you'll work with your co-op or your neighbors to work at a centralized fermentation, because that's where you've got the highest likelihood of hitting thermal success. All right, so when fermenting at a fermentary, is it better to open the pods at the farm and transport the wet beans, or to transport the pods to the farm, to the fermentary, and then open them there? And I'd say both of them can be good. I think there are pros and cons. I prefer collecting the wet beans at the farm, and I typically like doing it overnight because that's when the temperatures are lower. And why do I like lower temperatures? So remember, we talked about fermentation is just yeast eating the sugar of your pulp. So if you're at your farm and you open up your pods, well, that yeast is everywhere. It's in the trees, it's on your hands, it's just everywhere. You don't need to add anything for that yeast to be present. As soon as you open up your pods and you've exposed your wet beans, yeast has landed on it and fermentation starts immediately. Fermentation happens as a function of temperature. And so if you're doing that during the day when it's hot, your fermentation is going to be a little bit more vigorous and you're going to eat more of the sugars away. So by the time you get it to your centralized fermentary, your bricks are going to be a little bit lower than they would otherwise be. If you collect them at night where your temperatures are lower, even though the yeast is on there and it started fermenting, that fermentation is happening slower now because it's cooler temperatures, and your bricks is going to be higher by the time it gets to the fermentary. So that's one reason I like collecting at the farm. The other reason I like collecting at the farm is that, well, there's two reasons. One is that oftentimes your trees are not fertilized, and if you're taking your pods and your tree is taking nutrition out of the soil, right? It's pulling nitrogen and phosphorus and all these nutrients out of the soil and able to make the pod. Well, if we take that pod and we move it elsewhere, right? We bring it over to a central fermentary and we open it there. That central fermentary is just going to take those pods and they're going to throw them out in their backyard someplace. Those pods will break down and then they become fertilizer for, just wherever they're thrown, which means you're taking nutrients out of your farm and sending them somewhere else. I like taking the pods and keeping them on the farm, because then you can then turn those into mulch that you can then use to fertilize and put nutrition back into your soil, so you've got healthier trees over time. I don't like the idea of continually taking nutrition out of your soil and putting it someplace else, because over time, what happens is your trees get sick. And now they can't fight off diseases effectively, or they can't generate as many pods because they're just sick all the time. There's not enough nutrition in the soil. And I can help you guys if you like. I can help you understand how to create some fertilization materials out of your pods to be able to put that back to your trees. The other thing that we risk doing is transporting diseases around your region. And so if you've got a specific disease on your farm that maybe nobody else has, or some specific pest infestations, well, if those are on your pods and now you're moving pods through your region, you're now risking distributing that disease throughout the rest of the region and making it a bigger problem than it would need to be. So for those reasons, I prefer opening at the farm and then at night and then transporting to the fermentary. All right, so what's the best type of fermentation? I prefer the boxes for reasons we talked about. We get better standardization. You can standardize the fill weights and the drainage and turnability, although there are pros and cons to everything. And so hopefully from today's conversation, you're able to understand what's happening at each stage of the fermentation so that you can understand and customize your fermentation to be able to direct it in the way that you want to go. I will almost always, if not always, recommend a box fermentation. The specifics of that box can change from site to site depending on what we're trying to accomplish, but that's where we're going to find the most controllability. I think we talked about the to drain or not to drain. If you're looking to get a very, very sour bean, what we'll do is we'll turn the beans a lot and we won't drain them. Again, if our goal for Jamaica is to create cocoa of excellence level fine flavor beans, we're going to want to drain because we're not going to want to drive sourness into our flavor profiles. So why do the beans look purple or brown inside? We talked about that a little bit at the beginning. That purpleness is coming from flavonoids, which are naturally occurring chemicals that are heart healthy. When we ferment, those purple heart healthy compounds change during the course of fermentation. The alcohol changes them, the acid changes them, and they turn into something else. Some of what they're turning into would become the fine flavor things that we want to see in our cocoa of excellence chocolates. The balance that we have with these is that oftentimes people will want to say, okay, I want to get as many heart healthy things into my chocolate as possible. And we can do that. And I have done that for some customers around the world. The trade-off when you do that is that those purple heart healthy flavonoids don't taste very good. They're very, very bitter. And so I can make a chocolate, I can create a fermentation protocol that will be very, very heart healthy, but you're going to lose out on flavor. If we try to get to the fine flavor side of things, which is where Jamaica wants to go, we're going to lose out on some of these flavonoids. We're going to want to process them out. And when we get to the point of creating specifications for your beans, and we'll talk about that on Friday a little bit, one of the ways we'll measure that is by doing cut tests on your dry beans and then counting how many of them we see purple in, because we're going to want to minimize the amount of purple we're seeing in our beans, because those are going to contribute to flavor profiles that are going to be bitter. Okay.
Scott, there's a quick question from Meldros before we move on, and that's just in regards to what woods we would use. What woods have you used in other places? I know here in Jamaica we use a wood called guango. What other woods can you use?
Yeah, so I'm not familiar with the specifics of your local trees. Typically, good protocols will be saying don't use woods that are what we're going to call sap woods, right? So don't use trees that generate lots and lots and lots of sap, because those are going to contribute to flavors. And so typically what we're looking for is low sap hardwoods. There are going to be exceptions to that rule. In some places, and again, I don't know if this is the case for Jamaica, but in some places there are low sap hardwoods that are really, really poisonous. So obviously don't use those in creating your boxes that are going to, put, you come into contact with things you're going to put in your mouth. But so as a general rule, low sap hardwoods. Okay. So this is the cut test that I just mentioned. We'll talk a little bit more about this on Friday, but what a cut test will help you do is understand that, all right, once you completed your fermentation protocol and you've dried your beans, we'll talk about that specifically on Friday. How do you know if your beans are going to be what you think they are? One way that we can do is cut your beans in half. And so this is something called a Magra book cutter or a guillotine cutter, where you put 50 or 100 beans inside this. It closes up and there's a knife that cuts down it to split the beans in half, and then you open it up and you can count, well, how many purple beans do you see? So some customers are going to want to see lots of purple beans because that's what is giving them what they're going to want. For you guys, you're not going to want to see a lot of purple beans. And so we'll want to create specifications for, all right, on the other end of drying, once we've finished our processes and we've done everything that we're going to do with them, let's cut 100 of those beans in half and say, all right, I'm going to make the numbers up because I don't know the answer right now for you today, but we don't want to see any more than 2 purple beans every time we cut 100 beans, because if we're seeing 6 or 10 or 20 purple beans, then we know that our chocolate's going to be very, very bitter, and that's, something has gone wrong in our process that we need to investigate. Again, so we'll spend a little bit more time on this tomorrow because this is going to be something that specifically follows drying. We'll save this for Friday as well, because this is going to be a little bit more insightful. Each color tells us a little bit something more. And I do want to be sensitive to time, so that's kind of why I'm going a little bit quickly now. So key points, key takeaways. So it's really, really important. If I'm summarizing what we just talked about, it's really, really, really important that you start with a ripe, non-diseased pod that is giving you good quality beans. And by good quality beans, what I mean are beans that are greater than 13 bricks. Now, you can also use those beans to create a really wide range of flavors by adjusting your fermentation times, your turns, and your drainage, right? So what I want you to think about is your beans can create a whole range of products that you can use to generate different flavor profiles for different customers. And I'm going to propose some fermentation trials that will help us understand and map those out so that not only do you understand how to get there, but we'll create some marketing materials, if you'd like, to be able to market your beans to people along different flavor profiles. Turning your beans frequently is going to create sour flavors. We're always going to want some acid developed, but if you turn a lot, you're going to create more acid than your flavor profile is going to be able to handle. Your fermentations are also going to be very sensitive to mold and should never run longer than 7 days. I suspect for what we'll find for you guys, in order to hit Cocoa of Excellence fermentations, we're probably going to be in the 5 to 6 day fermentation. Okay. Consistency is going to be really, really important. So once we do some trials and we map out exactly what the fermentation protocol, exactly what the drying protocols are, and we overlay on that some sensory work to say, all right, if I ferment and dry this way, I get Gold Star Cocoa of Excellence, chocolate on this side. We're going to want to create a process for doing that, and doing that process consistently will ensure that every time that you ferment your beans, that you're going to have Gold Star Cocoa of Excellence, award-winning beans coming out of that. So that what that means is that if we say it's a fermentation, let's say I'm going to make things up, it's a 4-day fermentation that has 1 turn after 2 days. We're going to want to be more specific. We're going to say, instead of 2 days, exactly at 48 hours after we've started fermentation, that's when the beans get turned. It's not 50 hours, it's not 46 hours, it happens exactly at 48 hours, okay? There are some simple pieces of equipment that will be really helpful for you in understanding your fermentation. The refractometer we talked about, and a thermometer or a data logger. You can buy both of those things for less than $50 and will be just super helpful in helping you manage your fermentation. And we'll talk about drying on Friday, and I'll give you some tools that you can use there. So I know I'm speeding up here a little bit, but I'd like the next few minutes to be a little bit more conversational. And so if I'm going to come back on next Monday with a proposal to conduct some fermentation trials, what I'd really like to understand from you guys is to get a better picture of how you're currently fermenting. Are you using boxes? Are you using drainage holes? Are you using something else? How much do you ferment? Can you talk to me a little bit more about how you collectively are fermenting and what kind of results you're getting when you do your fermentations as you normally do them? Everybody's too shy to be the first to go. Is that what we're seeing?
I'll jump in super quick.
Hello.
Part of the problem is we've never really done this. That's part of the problem, if we're being truthful.
Okay. Ilian, were you going to offer something? Okay, sorry. I thought I heard somebody else starting to talk. Okay, so that's fine. If there's not, if this is something that has not been done before, if there's not a standard way that you guys are doing it now, that's actually better, right? Because we're starting with a blank slate, and that allows me to sort of design it from the beginning, as opposed to trying to modify something that's already in place. So that's fantastic. So the next time, guys, what we'll do on Friday is, I hope this has been helpful, and I really appreciated the chance to talk with you guys about the basics of fermentation. And this is really meant to be just an introduction to fermentation, and we can go as deep as we need to go later, but to sort of manage the time and to set a baseline understanding of what's happening, this is a very good, introduction conversation. On Friday, when we do our next conversation, what I'll do is I'll leave the first part of the time for questions and answers, because you're all going to go back and you're going to maybe watch this, or you think about what we talked about and go, boy, Scott said something I didn't really understand, or I now have a question that I didn't think about when he was talking. So I want to make sure we've got some space to have a conversation around that. And then once we go through that, we'll do the same thing with drying. We'll do a drying introduction to talk about what are different ways of drying and what's important in managing drying processes. And then on Monday, which will be our third conversation, we'll do the same thing. We'll have a question and answer where we can pick up any fermentation questions that still exist, or any drying questions. But at that point, I'm going to come back to you guys with a proposal to conduct some a two-phased fermentation trial with the purpose of creating beans that our good friend Nick will then convert into chocolate, and then we'll evaluate using Cocoa of Excellence standards. Again, I'm a judge, so I'm pretty familiar with the process. We'll evaluate those and create some marketing materials that could be used to help sell those in and map the flavor processes, or to modify them for another round of fermentation to build upon what we learned in the first round. And the second thing that I'll do is I'm going to propose a fermentation design protocol that is going to be very specific to creating very specific types of chemicals during fermentation, again, with the intent of bolstering your chances of creating a range of products that will win Cocoa of Excellence awards and generate multiple types of high value cocoa products. Okay. So the last thing I'm going to put up is, this is just my email. I want to be as accessible to you guys as possible, right? And so I understand that this is a lot of me talking about some pretty technical things, and I probably put half of you to sleep. So for that, I apologize, but I want to be accessible so that over time, as questions pop up, or even a year from now, as you get into fermentation and something doesn't make sense to you, or you've got a problem, just give me an email, contact me somehow, and my goal is to help you increase your level of knowledge and understanding so you can generate more value for your products. Okay. So that's what I've got for today.
Yeah, thanks, Scott. Gary Watson here from JACRA. I just want to say that your presentation was excellent. I believe others would join me in saying that, we have learned quite a bit, and, we look forward to the other few sessions. And, it's really wonderful, the work you have done. Thanks for everyone who have logged on, and we look forward to seeing you on Friday and Monday, respectively.
Thank you, Gary. I appreciate it. Okay, guys. Well, if there's no other questions, then I do want to be sensitive to your time. I know that I've kept you longer than we said we were going to keep you. So
we have 12 minutes. Elian, I think, had a question for you, Scott. I don't know.
Okay.
Elian?
Oh, hi. Yeah, I was I was very, very late, but I've not heard the first part. But what I'm asking, can beans be stored in the refrigerator?
Can wet beans be stored in the refrigerator?
Yes, to ferment.
Let me think.
I mean, I heard you talk so much on the temperature. So I was wondering if it could be stored and then ferment.
Is your question, can they be fermented in a refrigerator that's cold, or fermented in a cooler that isn't actively cooling but is containing the heat?
I think what he's saying, Scott, excuse me, I think what he's saying is that can you store the beans? You reap the beans, store them in a refrigerator for a period of time, and then do the fermentation.
Yeah.
If that would affect the fermentation.
Yeah, exactly.
Okay. Yeah. So let me repeat that just to make sure I understand. So can you harvest the beans, store them in a refrigerator so their temperature isn't is kept low, and then transport them later to ferment in bulk? Yeah, I've never done that. That's a good question. My gut reaction is that you probably could. I wouldn't want to do that for a long period of time. But if it's for a day or two, probably, I would probably want to seal them up. I wouldn't want them just lying open in the fridge, because one of the things we didn't talk about, just a little bit more advanced, is oxidation profiles. So if you just put them in a fridge and they're uncovered, they're going to oxidize, which we don't want to have happen. So I would put them in a bag or somehow cover them. But I would think that if you did that, if you had them sealed up and in a fridge for a day or two, so a temporary storage just to get them to where they're going to be fermented, I think that would probably be okay.
Okay, yeah, just to slow the fermentation process, I guess. Yeah, I don't see why not.
Yeah, that would be. I think that's the reason why he would suggest it, is that if you're concerned that you're going to be opening them and you know that fermentation starts immediately, and you know that the warmer the beans are, the faster that fermentation happens, but you're not ready for it yet, can you slow it down by storing them in the fridge temporarily, such that you haven't fermented all the sugars away, but whatever time you get it to the central fermentary? I think that probably would work. I've never done it, but the science I don't see a problem with it if you seal it and you don't do it for long periods of time.
Oh, yeah. Okay.
Interesting question.
But do we have a variety that we for processing? Are there varieties in the cocoa plants?
There are, yeah, and you guys have been blessed with some of the best varieties on the planet. So I can't tell you exactly which variety you have, but just know that the island of Jamaica has some of the best varieties on the planet. You've got very good plants to work with.
Okay, thank you.
Yeah, of course. Okay. All right, guys. Well, if there's no other questions, I certainly do thank you for the time and look forward to round 2 of our conversation on Friday.
Okay,
Great.
thank you.
Have a good day.
Have a good day,
Thank you
guys.
very much.
Okay, Scott. All right, guys. Thank you so much for
Who's the host? Hi, hello.
attending. Yes, Mr. Dawkins.
Yes, I'm trying to find out the host. And am I going to get recordings? Because I was extremely late, and I'm sorry about that.
Did you leave your email in the chat?
I'm not so good at chat.
I know. There's a box at the bottom. I don't know if you can. If you can just right.
No, I think Mr. Sims has Mr. Dawkins' email through WhatsApp. Yes, so we'll send it through to Mr. Dawkins.
We have your contact, Mr. Dawkins.
We have the contact, Mr. Dawkins, from the last training session, so it will be forwarded to you.
Oh, okay. Thanks.
Hi, Marsha.
How are you? Do you have a question?
No, I just saying hi.
We appreciate the vibes. All right, guys. So this has been a very. Didn't I tell you that Mr. Johnson was spectacular and he's a magician? He is, and he proved it today. It was a very technical training, and it's food we're handling. It's about safety. It's about best practices. It's about improving what we're doing, and it's about finding new industries throughout Jamaica. Agriculture is not where it used to be and not where it's supposed to be. And this is one avenue where we see Nick has been doing tremendous work in the field. Jakra, my good friend, Mr. Watson, they're trying to revamp this industry to the point where Jamaica can be recognized as a country that produces fine chocolate. But as Scott says during his presentation, and a hallmark of harvesting and post-harvesting is that at the end of the day, you cannot improve the quality of anything that you reap. So if you reap tomatoes and they're spoiled, you cannot convert them into being good tomatoes. So the principle which has carried throughout the training is that you have to preserve the quality that you reap. So it makes no sense for you to reap maybe, let's say 100 pounds of good quality beans, and then you have 5 pounds just to make the weight. You're gonna compromise it with the poor quality. So good quality, good quality, good quality, maintaining that good quality post-harvest, after you harvest, is very critical to the process of good fermentation. So if you get nothing from it, guys, remember quality, 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 quality. At the end of the
Mr.
day.
Nick get his beans.
Mr. Nick,
how do you get your beans? I'm not hearing you.
You're muted.
Currently, the way, and a lot of this fits in with the issue which Scott has mentioned, or what I mentioned with Scott. At the moment, there's only 2 ways to be able to get your beans. That is to either go through JACRA and go to what was the Cocoapod, or you go directly to 2 other farmers groups. Those are the only 2 options. If you look
because
at,
I know the guys in the area used to plant a lot of cocoa and they used to sell it to the Highgate chocolate place. So since you are in St. Mary, I thought that was just the same process, but I realize nowadays there is not much chocolate around.
Listen, we have a lot of chocolate here. The problem is we have, because of the fact that people weren't getting paid enough money, people have decided to throw out their cocoa, which is also part of the problem. And so we either need to rehabilitate our farms, or we need to be able to find quality and put quality at the front. And that's the way that people are going to get paid and people will get back into it. But the quality of cocoa is here. The cocoa is here. We just need to be able to get people to be invested in doing it. You know, because since I came back to Jamaica, there was 1 chocolate factory, 1 chocolate company. There's now 7 in Jamaica. Okay. So we may be small, but you know, we're little but we tower, and we're getting there. But we need the support of the farmers, and we need to get people fermenting, and that's what's going to make the change.
And I'll see that I think the potential, Jamaica will become a world-class cocoa region, right? It will happen. How quickly it happens is up to you, right? And I can certainly help you get there, but you have everything you need to have some of the best, if not the best chocolate on the planet, which is crazy exciting, right? You will get there. And to Nick's earlier point, when you have the best on the planet, people will pay $5,000, $7,000, $10,000 a ton for that. You will get there. And I don't.
How many pounds is in a ton?
Yeah, I don't want you to think about success as being how many cocoa processes there are in Jamaica. That's important. We want to do that. I want the world to be competing for your beans, right? The world will recognize Jamaica as having some of the best, if not the best, chocolate on the planet. That's where you guys have everything you need to get there. We'll just help you figure out how do you pull that out of your beans and how do you get it. This is very exciting. You've got the best genetics of almost anywhere I've worked.
2,000 pounds in a ton. 2,000 pounds in a ton.
And that's 10,000 US.
Yep.
Okay.
No, 2,000 pounds in weight.
Yeah, 2,000 pounds in weight. Yeah. Right. Okay, everybody. Right. See you on Friday.
Happy Friday.
Okay.
Cheers.
So it's gonna be the same link, guys, at the same time. Mr. Lewin, you had any?
Thank everyone for participating today, and hoping to see you on Friday. The recordings will be sent to you. Please fill out the link that's in the chat. And that's how the recordings will be sent to you. And thank you again. I hope to see you all on Friday.
Okay, thank you. Thank you very, very much. This was very informative and I really enjoyed it.
Mr. Barnett, maybe Friday you can tell us what you do because you're the instrumentalist, right? Or that's not the word.
Yeah, well, we do fabrication and machine building in the agro sector in Jamaica. So I'd really love to stay in touch with you guys and be a part of the transformation of the cocoa industry.
Thank you so much for joining.
Thank you.
I appreciate it.
Maybe you can design some special boxes for fermentation. Some boxes that
Final
are
words to
designed.
all participants. These trainings that we usually keep, yes, you can use these use these as outreach and for networking, because if you notice, you have people from all different stations, all different type of people in the training. So it's up to you to connect with other members in the training. You may never know, you may have some idea that you have been thinking of that person was also thinking of. So please use these trainings to network also.
I've just finished doing general agriculture at IVPT Spring Village, and I'm just going through the rows to see which better fit, which agricultural area is best to fit in. So as long as I have the land, I will be interested.
Okay. Well, we keep all different types of training. So once you are in touch with us, you will know the technical trainings that we provide, all different levels of technical trainings, because after this, cocoa fermentation, it will be apiculture.
Oh, I'm interested in that one as well.
Right. So once you are in contact with us and we have your contact, the links and the invitations will be sent to you, which is why it is imperative for you to try and fill out the form, because when you fill out those forms, your information is stored in a database, so we automatically can send recordings or invitations to you.
Okay, thank you.
Welcome.
All right. I'm looking if there's anything in the chat. All right, that sounds like a wrap. So Mr. Barnett, maybe Friday you can tell us quickly some of the equipment that you currently can produce and are producing. I don't, if you have pictures and you could send a quick project as well.
Okay. All right. Thank you for that offer.
All right, great.
All right.
All right.
Could you send me your email address, and then I could probably send them ahead, because I may be on the road on Friday.
Okay, no problem.
All right. Thank you very much.
I remember you from way back with the soil machine.
Oh, all right.
Yeah, we need a cocoa stripper.
A cocoa. There you go.
Stripper. Okay.
Oh, yeah, but design for a cereal stripper, I know.
Well,
yeah, you see what I'm saying? I need something that needs to be patented for the stripper cereal.
Well, not a problem. So we worked with one company locally, and they produced a patentable design. We just fabricate, and we're willing to sign non-disclosure. We can keep those discretions, you know.
Yes.
The gentle people, you see what is called networking.
Okay.
That is called networking.
Mr. Barnett, can you just put your information in the chat again? It was at the top, but some persons have joined late, so they would not have access to the chats before.
Okay.
Your organization. Yeah.
Sure, not a problem. Garrett, when you said can you tell us which organization you're from? Because I'm not familiar, to be honest.
I'm a field officer for Partners of the America.
Okay. All right.
Yes, sir.
All right.
He's the one hosting you here.
Yeah,
so we're USAID Farmer to Farmer.
Yes, USAID Farmer to Farmer, Partners of the America's Jamaica branch. I'm actually the field officer who is responsible for this assignment, but we're a team. So Miss Marsha Johnson, as you have met, she's our country director. There's also Mr. Ranil Sims, who does a lot of the work on the background, building those web pages. And there's also Miss Simone Williams. She's on here with us too. She keeps everybody in line. So yeah, that's the team. So thanks again. I'll even leave my contact information in the chat also.
Yes, please. Thanks.
Thanks much. Bye-bye.
All right, everybody. See you on Friday. Okay, bye.
Hello.
People still want to get admitted.
Dwayne,
You see that?
I saw him. I just let him in. I have to send the email to him. And St. Catherine has a lot of chocolate. Mr. Smith?
But he had contacted me before and I sent the link to him because remember he's my classmate.
Okay.
Yeah.
All right. You can send it to him
Yeah,
afterwards.
man, he had all the links and everything. So
Mr. Smith, we're wrapping up. So we meet again on Friday on the same link at 1 o'clock. All right. All right, everybody, have a good afternoon.
and thanks again.
Thank you.
Okay, no problem.
Thank you.
Still fine.